Most car buyers make their decision at the fuel pump, comparing the price of petrol to the price of diesel. But focusing only on the cost per liter overlooks the mechanical reality of how these two engines actually function. Every difference in how these vehicles drive and how much they cost to own over time starts with one specific divergence in how they handle heat. A petrol engine relies on spark ignition. It draws a pre-mixed combination of air and fuel into the cylinder together, where it waits for a trigger. A diesel engine uses compression ignition. It draws in only air, squeezing it so tightly that the air itself becomes hot enough to ignite fuel on contact. This side-by-side shows that moment of ignition. On the left, the petrol engine uses a spark plug to create an electrical arc. On the right, the piston compresses the air until it's superheated. Then the injector sprays diesel directly into that heat, causing it to self-ignite instantly. Because it relies on that spark, the petrol engine requires a complete ignition system, including spark plugs and coils, that must be maintained and eventually replaced. The diesel engine has no spark plugs at all. Once the engine is running, the physics of compressed heat handles the ignition automatically. This choice, how the fuel is coaxed into burning, sets the stage for the vehicle's weight, its pulling power, and its eventual maintenance profile. To understand why these engines behave so differently, we have to look at their internal geometry, specifically the compression ratio. A petrol engine operates at a lower compression ratio, usually between 8:1 and 12:1. If you squeeze the air-fuel mixture any tighter, it would explode prematurely, causing the engine to knock. But a diesel engine requires a much higher ratio, ranging from 14:1 to 22:1, just to generate enough heat for that self-ignition to happen. That extra pressure impacts efficiency. Diesel engines convert roughly 35 to 45% of fuel energy into mechanical work. Petrol engines convert only 25 to 35%, extracting more work from every drop. However, surviving that 22:1 compression requires a trade-off. The engine block and internal components must be cast much thicker and heavier to withstand the internal pressure. That extra metal adds significant weight to the front of the vehicle, which changes the power-to-weight ratio. This weight is exactly why you don't see diesel motorcycles. The heavy engine components required for compression ignition would make a small vehicle sluggish and difficult to handle. Diesel offers higher efficiency, but it comes at the cost of physical bulk, which limits the types of vehicles it can effectively power. A petrol engine controls its output by using a throttle to restrict how much air enters the cylinder, maintaining a precise balance between air and fuel. A diesel engine pulls in as much air as possible and controls its power purely by varying the amount of fuel it injects. Because a diesel doesn't have a throttle valve fighting against the incoming air, it avoids pumping losses, which further improves its efficiency during city driving. These differences show up on the road. Because petrol engines have lighter parts and a balanced fuel mix, they can rev much higher, often reaching 6,000 RPM or more. This makes the engine feel responsive and quick to accelerate, delivering its peak power at higher speeds. Diesel engines are limited by their own weight and high internal pressure. They typically redline around 4,000 RPM, but those heavy parts and long strokes generate massive low-end torque. This is the strength required to pull a heavy load up a steep incline. Ultimately, petrol is engineered for high-speed agility, while diesel is built for raw, low-speed pulling strength. The way fuel ignites also changes the sound of the drive. In a petrol engine, the spark creates a smooth, controlled flame. Diesel ignition is more violent. The fuel explodes almost all at once, which creates the characteristic clatter and the vibration you feel through the steering wheel. To quiet that noise, manufacturers have to add heavy sound-dampening materials, which adds to the vehicle's weight and its price tag. Then there is the chemistry. Because diesel burns with excess air at high temperatures, it produces higher levels of nitrogen oxides and soot. Petrol burns cleaner by comparison, usually requiring only a simple catalytic converter to meet emission standards. To meet modern standards, diesel engines require two expensive systems. Exhaust hits a particulate filter, trapping physical soot. If you only drive short distances, it clogs, requiring a long highway run to burn it away. The exhaust then moves to the SCR system, which requires a fluid called AdBlue. Without it, the engine's computer restricts your speed to keep emissions in check. While diesel fuel might be cheaper, these complex emission systems have increased both the initial cost of the car and the amount of maintenance it requires over its life. Neither of these engines is a better choice in every situation. They are specialized tools designed for very different types of driving. If we look at this matrix, balancing the weight you carry against the distance you drive, the choice becomes much clearer. If you are a city commuter or a light driver, you land firmly in the petrol zone. For this lifestyle, petrol makes the most sense. You avoid the high upfront costs and the risk of clogging a diesel filter on short trips to the store. But if you are a commercial operator, a regular tower, or a long-distance highway driver, you are in the diesel zone. In this case, the fuel efficiency and the low-end torque are valuable enough to pay back the higher maintenance and purchase costs over time. The most expensive mistake you can make is buying a diesel engine for a short, light-load commute. The fuel savings will never outweigh the specialized maintenance costs. When choosing your next vehicle, look past the price at the pump. Match the mechanics of the engine to the reality of your daily drive.